Hello, Algebra 1. Today we are doing integer, 0, and negative exponents. Our goal is by the end of class you will be able to evaluate expressions containing 0 and integer exponents and simplify expressions containing 0 and integer exponents. Homework today is exponent and polynomial. We're at sheet number 1, and it is going to be in the packet. So what's the pattern? So when we look at the top row, we see our powers, 5 to the power of 4, 5 to the power of 3, 5 to the power of 2, etc. Down below, we see what they equal to, the value. So 5 to the power of 4 equals 625. 5 to the power of 3 equals 125. So to get from 625 to 125, we have to divide by 5. To get from 125 to 25, we divide by 5 again. To get from 25 to 5, we also divide by 25. So the pattern here, that's the real question. What is the pattern? Well, we're dividing by 5 each time. So 5 divided by 5, that gives us 1. Then we're going to go ahead and do divided by 5 again. 1 divided by 5 is 1/5. Once again, we're going to go ahead, divide by 5. If you want to do that math over here, 1/5 divided by 5. Remember, when we have to divide a number, we're really multiplying by the reciprocal. So 1/5 times 1/5 equals 1/25. So notice the pattern here. In the two spots that I just highlighted in red, 5 to the power of 2 is 25. 5 to the power of negative 2 is 1/25. Okay? So when we go ahead and move down here to 5 to the power of 0, anything to the power of 0 will always be 1. 5 to the power of negative 1, we put our 1 in the numerator. And then what it's really saying, 5 to the power of positive 1, 5 to the power of 1 is just 5. So 1/5. When we do 5 to the power of negative 2, we'll go ahead and put 1 in our numerator. And then 5 to the power of positive 2. 5 to the power of 2 is 25, so 1/25. All right, so moving on down to exponent rules. For the 0 exponent, any non-zero number raised to the power of 0 is always going to be 1. So that means 14 to the power of 0, that is 1. X to the power of 0, that is also 1. With negative exponents, if you see a negative exponent, your solution is not going to be negative. Let me write that in red because I really want that to stick out. Your solution is not going to be negative. Simply remember to change your exponent. Remember, we change our exponent by moving it to the denominator. So when we come down here to 6 to the power of negative 2, to make that 2 positive, we move it to the denominator. So 6 to the power of positive 2. 6 to the power of 2 is 36, so our final answer is 1/36. When we have variables, same concept applies. Y to the power of negative 5, we need to change our exponent to be positive. Remember, to do that, we need to put it in the denominator. So 1/y to the power of positive 5. All right, we have some more examples here. Example 1, 4 to the power of negative 3. Remember, we need to make it positive. Change your exponent. In order to do that, we are going to put it in the denominator. So 1/4 to the power of 3. 4 to the power of 3 is 64, so 1 over 64. And then for our next one, remember, anything to the power of 0 is always 1. So 7 to the power of 0 is 1. Go ahead, pause the video, think about example 2. Are these two problems different, and how does that impact your answer? This is going all the way back to chapter 1. All right, I give you a little hint here. Hopefully you paused the video and tried it on your own. Remember, if there are parentheses around that negative number with an exponent, that negative sign goes with all of the numbers. However, if there is no parentheses around that negative 5, there's a negative sign out front, and then it's just 5 times 5 times 5 times 5. But another thing we need to factor into this is we also have a negative exponent. So remember, in order to make that exponent positive, we move it to the denominator. So then we have negative 5 to the power of positive 4. And then negative 5 times negative 5 times negative 5 times negative 5 is 625. So we have 1 over 625 as our final answer. Moving over to the other problem, negative 5 to the power of negative 4 without parentheses. We are going to go ahead and make that exponent positive by moving it to the denominator. So negative 5 to the power of 4. We know that 5 to the power of 4 is 625. But remember, we're going to have a negative sign out front there. So then it'd be 1 over negative 625. And that would be your final answer. All right, moving on to example 3. Substitute and simplify. So remember, we're going to take what x equals in this first one and substitute it in. So x equals 4, so we're going to write 4 to the power of negative 2. We want to make that exponent positive, so we move it to the denominator. So 1 over 4 to the power of positive 2. 4 to the power of 2 is 16, so then our final answer is 1 over 16. We're going to go ahead and do this next one. We're substituting 5 in for A and negative 3 in for B. So we get negative 2 times 5 to the power of 0, and then negative 3 to the power of negative 4. Remember, anything to the power of 0 is just 1. So I'm going to rewrite this, negative 2 times 1. And then negative 3 to the power of negative 4, I'm going to go ahead and make that positive by moving it down to the denominator. So then we get negative 3 to the power of positive 4. All right. Negative 2 times 1 is negative 2. And then negative 3 to the power of 4, that is saying negative 3 times negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is a positive 9. And then negative 3 times negative 3 is a positive 9. 9 times 9 is 81. All right, so then our final answer there is negative 2 over 81. Go ahead, pause the video, and then do these next two examples on your own. All right, here are my answers for these next two problems. 5 to the power of negative 3. Remember, we want to make that negative 3 positive, so we move it down to the denominator. So we get 1 over 5 to the power of 3. 5 to the power of 3 is 125, so we get 1 over 125. Then for our next one, we have to substitute in negative 2 for A and 6 in for B. So when we do that, we get 8 times negative 2 to the power of negative 2 times 6 to the power of 0. First thing I'm going to do is I'm going to move that negative 2 to the power of negative 2 to the denominator because I want to make that negative 2 exponent positive. And then 6 to the power of 0 is 1. Anything to the power of 0 is always going to be 1. And then I'm going to simplify. 8 times 1 in the numerator is going to be 8. And then negative 2 to the power of 2. Since we have parentheses, we're saying negative 2 times negative 2, which equals 4. The last thing that I did not do, 8 over 4 reduces to 2. All right, then we have example 4. So for this first one, 7w to the power of negative 4. I really want to focus on this one because this is where a lot of students make mistakes. They move everything to the denominator, and that's not the case here. 7 does not have a negative exponent with it. Only w does. So we are only moving w. So what happens here is 7 will stay in the numerator, and then w needs to move down to the denominator to make our exponent positive. Again, 7 does not have a negative exponent with it, so we don't change it. All right, moving on to the second one, 2r to the power of 0, s to the power of negative 3. I'm going to go ahead and write this out. 2, remember anything to the power of 0 is 1. And then s to the power of negative 3, we want to make that exponent positive. So in order to do that, we need to move it to the denominator. So when we move it to the denominator, it becomes positive. 2 times 1 is 2. And then s to the power of 3 will stay the same because we've made it positive now. So our final answer is 2 over s to the power of 3. All right, go ahead and try everything in example 5 on your own, and then I'll post the answers here in a second and talk about them. All right, for that first one, we need to make m to the power of negative 3 positive. In order to do that, I need to take m to the power of 3 and move it to the denominator. So when I do that, I get 1 over 7m to the power of 3. 7 does not have a negative exponent, so we don't change it. It does not move. Looking at my next example, I have negative g to the power of 4 over h to the power of negative 6. All right, so pay attention here. The g does not have a negative exponent. 4 is not negative, so it does not change. However, h to the power of negative 6 is a negative exponent, so we move it from the denominator up to the numerator to make it positive. So our final answer is negative g to the power of 4 times h to the power of 6. Moving on to our last one. Remember, anything to the power of 0 is always going to be 1. So a to the power of 0, I change that to 1 in parentheses. B to the power of negative 2, remember, to make it positive, I am going to move it to the denominator. And then c to the power of negative 3, in order to make it positive, I'm going to take it from the denominator and move it up to the numerator. And then d to the power of 6. The 6 is positive, so it's not going to change. So our final answer, we get c to the power of 3 over b to the power of 2 times d to the power of 6. All right, remember worksheet number 1 is in your packet. Go ahead and get started on it now.